Hello, welcome to our very first elementary science just in time for grade 4. Today, we're going to be going over some key topics that is going to be in a unit that is coming up. And before we get into that, let's meet your presenters. My name is Wendy Lynn Island. I'm the dual language curriculum coordinator for math and science. And I'll also be joined by Askia Little, who is the elementary science curriculum coordinator. And for today's agenda, first, we're going to have a unit overview of the unit that we'll be focusing on, which will be Unit 4. Then we're going to look at some student data insights to look at the recent trends and data that is moving and being guidance for this work. We'll also share some instructional strategies with you and some resources. So we're going to look at a specific lesson in Unit 4 that we're going to highlight. And then as a part of that, we're also going to give you an example of how to do the word wall, interactive word wall. Today's learning target is that I can identify the key content, instructional strategies, and available resources for the upcoming unit so I can plan effective instruction. So we hope that by the end of this session, you'll be able to have some more resources and to have a better understanding of the content so that as you plan your instruction, you can make sure that it's effective for your students. And the success criteria to know that you met the learning target is I can name the priority standards and learning goals for the upcoming unit. I can explain how recent student data informs my instructional planning for this unit. And finally, I can describe at least one instructional strategy or resource I will use to address student needs. So to go over the unit that we'll be focusing on, it'll be Unit 4. And the TEKS and the content focus for this unit are the following. So TEKS 4.8a, investigate and identify the transfer of energies by objects in motion, waves in water and sound. 4.8c, demonstrate and describe how electrical energy travels in a closed path that can produce light and thermal energy. And 4.8b, identify conductors and insulators of thermal and electrical energy. And the lesson that we're going to focus on is going to be lesson cycle 2. So that's going to be TEK 4.8c. And the key concepts in that lesson cycle are energy transfer, electrical circuits, sound and waves, and conductors and insulators.
Right. And now we're going to look at a few of the CBA questions, not the whole CBA, but the ones that are specifically tied to that second lesson in the unit that we're going to be working with. So, of course, the one is about circuits. So here's our first question. So I'll give you a second just to glance over that question. And then, of course, the answer to that one is C, that the electrical energy must travel in a closed path. That includes an energy source. Let's look at this one. It says select the bulbs that will light if the switch in the image was left open. And as you can see, this one is a hot spot. So, of course, they're referencing this switch right here. If that was left open, select the bulbs that would still light up. I'll give you a second to think about that. And so basically what they're wanting students to do, and it's actually a good idea, like if they're doing this on paper or if you're doing it digitally, just to like, okay, so pretend this one is open and so we know that it can't flow through there and like just draw the path. So I know I can take this and I can draw the path through here, making sure it goes through the source and it doesn't have to go through there. So I know that this bulb lights up. Same thing for this bulb here. Is there a way that I can get this particular bulb to light up? Well, no, because I have to go through here. So that bulb we know definitely would not light up. All right. Here's a little harder one. I remember this one from the star that it was on. I'll give you a second to read over this one. Again, this is another hot spot that requires students to um, pick two places on here. Very similar to the previous question. It's a good idea to, as we're doing this and practicing, that we try to draw the actual paths. And then this one is just a drag and drop ordering question. Turning on a lamp involves several steps that occur very quickly. Drag and drop the steps in the correct order. And so they would just drag and drop those particular steps in the correct order. Those were the four questions that are specifically related to the investigation that we're going to talk about. Now, just to give you a more broad overview of the unit itself, you got about 16 days for this unit. Each lesson cycle is technically, of course, 5 days. If you're looking at the unit flow document, the ones that don't say optional, those days 1, 2, and 3 are definitely the ones that we want you to get done. And of course, as time permits, there's a lot of other things that can be done. But you have 15 days for the instructional part, and then you have a day for the CBA. All right, we're going to move on into our second section today. And I want you to be able to explain how recent student data informs instructional planning for this unit. This is going to be very short. Um, this is what I have for you here. Of course, we did not have CBAs in fourth grade last year, so there is no CBA data that we can share with you for that. However, we looked at fifth grade STAR and we did a vertical alignment that you can see here. And our district performance, and this is a readiness TEAC, was only 55% on this particular standard. So we definitely have some work to go there. I'm going to go over some common misconceptions, and there's about 3 or 4 slides of these. So the first one is energy transfer misconceptions, because it's really important that as you're going through and having these conversations and teaching the students and the light bulbs are going off, that you pay close attention that some of these things are not cropping up in those conversations. So energy gets used up. Sometimes students think that energy disappears when objects stop moving or when devices turn off, rather than understanding that energy transforms from one type to another. Now, that energy transfer is new with the new TEACs. I remember when I first saw that, I was like, oh, okay, that's going to be something that we're definitely going to have to get students used to understanding. But that's a misconception that can happen. Second, they probably at this point may know what mechanical energy is, the energy of movement, but it's that energy only exists in moving things. So they may only recognize that kinetic energy, which is not a term they have to know, and miss that energy exists in many forms, such as sound, light, thermal, electrical. Third, energy jumps between objects. They may not understand that energy needs a medium, a pathway to get from one place to another. All right, and then when you start working on those circuits and putting those together, that's the lesson that we're actually going to talk about today. Some students may think that electricity gets consumed. They think that electrical energy is used up by light bulbs or other devices rather than transformed into light and the heat. And that's the terminology that we need to be using to get them there. They may say that current flows from both battery terminals. Sometimes students think that electricity flows out of both the positive and the negative end of the battery, and it's going to just meet in the middle somewhere. Um, Batteries are the only energy source. They may not understand that the battery provides energy that gets transformed by the circuit components. It's also a good idea to make sure, and I'll show you multiple images of types of batteries so they know that there's something other than that little D cell battery. They don't all look like that. Then we have the sound and wave misconceptions. This is actually the first investigation. And the very first question on the CBA is about this wave and this cork going in the water. So One misconception is that students think that waves transport the medium along with them rather than understand that waves transfer the energy through those particular things. Sound travels instantly. Some students don't recognize that it takes some time for sound to travel from one place to another and that it travels at a particular speed. Um, Lastly, on that, louder sounds travel faster. Sometimes students confuse volume with speed. And if I scream this louder, the sound is going to get there quicker. It's not the case. And then lastly, we have our conductor and insulator misconceptions. This is the very last investigation in this unit. Students think conductors are sources of heat and that insulators are sources of cold rather than understand that they simply allow or prevent that transfer of energy. Um, Next one is that all metals conduct equally. Some students may overgeneralize that, that all metals are perfect conductors or just because it's silver that it's a metal or something of that nature. And then lastly, that size affects conductivity. Some students might think that thicker materials automatically conduct better, and that is not the case. All right, so now I just want to go over a few suggestions for targeted support. Recently, right before the reasoning part of the claim, evidence and reasoning, we added a slide in the slideshows called Literacy Essentials. A lot of you may already know what that is. It's just a reading lesson type handout thing that you can assign it for homework. You can assign it if students finish early. You can assign it as remediation just to give students some more knowledge background that they can use. When they're writing their claim evidence and reasoning, they can use this knowledge as well. Other suggestions: do the total physical response, like do the motions, like it helps students to remember things and not just students who are emergent bilinguals. It helps all students remember things. Provide step-by-step picture cards showing how to connect circuit components. So once we get from the concrete, we didn't have to scaffold students to get to where when they get to that test question and they see that image of that circuit, they know how to answer that. Have students build multiple circuit configurations. We edited the investigation. So if you're using the one from last year or using something directly from McGraw-Hill, it's not going to have the edits in it because based on some feedback, we saw that students needed more opportunities to build different types of configurations. So we've also included that in the slideshow as well. One thing that you can do is intentionally provide a bulb that doesn't work for each group, or for some of the groups, just to throw that out there because they're like, oh, my circuit's complete. Like, what's wrong with it? Well, if the bulb has a component that doesn't work, then although it looks like everything's connected, it still doesn't work. That's something that they need to encounter. So, if now generally in my classroom, I didn't have to do this because there was always at least one bulb that didn't work, but test one to make sure it doesn't work and have that out there. Um, and then lastly, please, please, please make sure we're giving students the sentence stems and the sentence frames as the conversations for writing, specifically with the interactive word walls and handouts. Just make sure they have something to talk from. Okay, section 3, our instructional strategies and resources, says that I can describe at least one instructional strategy or resource I will use to address student needs. For this section, instead of making a different slideshow, thought I would just go ahead and show you the slideshow that exists. And here it is. Let me exit out of that because I want to show you some stuff in the notes as well. Um, I'm going to go through the slideshow for lesson 2. This is just for lesson 2. So there's, of course, that the waves and water lesson was the one before that, and the conductors and insulators is the one that comes after it. But we're just going to today focus on this one because that's what our data says that we should be definitely spending the most time on. All right. So, of course, again, we start with this slide here. You will see the TEAC in the notes. Please pay attention to the notes. We have the learning targets here. Here is our page Killy Probe, and this particular page Killy Probe, I'm actually not going to pull it up. You definitely need to just have students read through it a couple of times. There's only two choices. Basically, they're looking at an image of a circuit that's open and a circuit that's closed and deciding which one is actually going to work. So generally in fourth grade, they probably have done something like this. So you will have students that actually know the answer, but it is really important that you don't give the answer in this at this particular time. In the notes and in the notes of all of those, there is a strategy that's linked that you can use. There's a video on how to use it. This one is the commit and toss strategy, where the students write their answers on a little sheet of paper, stick it whatever, and ball it up and throw it across the room. Now, of course, if you don't want to ball up paper and throw it across the room, you can just have that up on the IFP, give students a half sheet of paper, and just have them like exchange several times, basically so they don't have their own answer, so that they can speak from that. The next part is just watching this video and generating some conversation. The video is literally just of the inside of a car as it's driving down the street, and you just click on the image here to get the video to pop up. If you need some questions to help you talk through that, that is down here in the notes section. All right, and then we have the actual investigation. Now, if you look down in the notes section of this investigation, you'll see here that I edited this investigation. The switch was added to that was not originally there. Because I edited it, there is a handout. The handout's also linked on the slide, but the new handout is here. And because I changed it from what was in McGraw-Hill, I put an answer key there as well. The video for this investigation is still linked there, but just know it does not include the switch because we added that. Now, let's take a minute and actually open up the investigation handout just so you can kind of see um, what this one is. So you're going to need hand lens, the light bulbs, the switch was added, wires, D-cell battery. Now, if you have other kind of batteries that you want to use, go forward. If you have other kind of lights, doesn't matter, as long as you have some similar materials. So the first thing it has them do is to think of the photo of the car's lighted heating control panel. How can you arrange the materials to make the light bulb light up? They'll look at those materials and they will more than likely just draw something here. Then it says choose a solution from your brainstorm. Hopefully, they did more than one, and they'll sketch that design below. Now, although we have these handouts, when I was teaching at the beginning of the year in classroom, I had the handout, but for the most part, all the parts that they could write in their notebook, we wrote in the notebook. I had a copy of the handout. I had it up on the board. There's some parts that you may need to actually print out, but where possible, have them do this in their science notebook. Next, it gets down to developing design. It tells them to use your plan to arrange the materials without the switch first, then test it. Does the light bulb work? If it doesn't work, try a different arrangement. The original investigation handout was a little less directive, but we really want to make sure students are getting all the experiences that they need. So we did add more to this one. Then it tells them to observe the bulb's temperature. Now, depending on what bulb you use, if you use the bulbs that came with it, they do get a very tad warm. If you're using LED bulbs or something like that, it's possible that the bulb may not get warm. However, the TEK says that it needs to produce light and heat. So there does need to be a discussion about the fact that it can produce light and heat. Again, it gives them some things to do. Remove one wire, what happens? Put the wire back, what happens? Then it says to add the switch. Doesn't tell them where to add the switch, but just to add the switch, flip it to close, flip it to open, and literally they're just going through. And then a challenge, can you make the light bulb work using a different arrangement that includes the switch? So different from what they did. The last part is really important where they're answering some of these questions. Now, what I've done when I've been teaching some of these lessons, depending on how much time was left, I highlighted a few that I thought would be the most beneficial. You can do that. You can have them, if you have time, answer them all. If not, highlight the ones you want them to answer, preferably in their science notebook, and do that. Lastly, the most important one is they do at this point need to make a claim. What do you think electricity needs to flow through materials and create energy? So after the investigation, I'll go back to the slides now. After they finish the investigation, the make it work investigation, then they will write their claim, which is the answer to the guiding question. And then they'll summarize their evidence based on the investigation. If you need help with what that should look like or could look like, below here we have our claim. We have an evidence that is a sample. Now we already know that the students are probably not going to write as much here, but this is an example of the type of thing that they could write there. And then if you need the framework, the CER framework is linked there as well. All right. The next part, we get to the exciting part, is the interactive word wall part. And we definitely don't want to skip this part of that particular lesson. All right. So here, I want to point out in the notes, you do have student graphic organizers that show like how the word wall could be organized. Doesn't have to be exactly like that, but it does show how the word wall could be organized. What I did for my students was I shrunk the size to like 90% or so, cut them all out because getting them to cut sometimes can be an act of Congress. And then I had them glue that in their science notebook so that as I was doing it on the wall, they would also have a copy of it for themselves. So for whatever reason, this one has 2 pages. Also, at the bottom of every one of these slides, we do have the word learning strategies that talk about cognates, context clues, word parts, related word parts. Sometimes gives TPR moves, but that's also in the script. So please, please, please make sure that you pay attention to those things. Whether you have Spanish speaking students, EBs, or not, it's a good idea to talk about those things because a lot of the stuff down there is just like language arts and reading lesson type things that they also need to know and they see how it also relates to science. Now, what we're going to do next, I put this slide here because I'm doing this virtually and I don't have a wall. So I made this slide so I can kind of drag and drop while I was reading this slide to you. So this is the slide that I'm going to be reading from. So you can see it has some highlighted words, of course, does have scripts at the bottom that I am going to be using for that particular slide, but I'm going to keep it for you on this so that you can see how we're building the actual word wall. All right, so put on your student hat for a minute, and we're going to go through just the first slide. And remember, I'm doing this particular slide. This is what you would have up on your IFP, and then you'll be referencing the word wall that you see here. And you would have already had this frame up on the wall so that all you have to do was write in the words or draw pictures or have students draw pictures to go on the slideshow. All right, we ready? All right, let's try it. So, hundreds of years ago, watching a lightning storm was the best way to observe electrical energy. Today, electrical energy powers lamps, toasters, computers, and other useful devices. You see that word in blue right there? That's our first word wall word. It's electrical energy. Everyone say electrical energy. Say electrical energy. Let's say it together one more time. Electrical energy.
Electrical energy.
Now, I also want to point out the word power that's in that definition. And notice that that word power can be both a noun and a verb, like when we say the power to do work, um, or we can say that something powers something, and that would actually make that a verb. Now, for our motion for electrical energy, we're gonna do our fingers like this and go bzzz. So everybody go bzzz. And whenever we see that term electrical energy, you can go bzzz. All right. All right. Let's continue reading. Electrical energy is a form of energy that gives some things the power to do work. This form of energy is also called electrical energy. A circuit is a complete and circular path around which electrical energy can flow. Now, we've come to our next word, and it's circuit. Say circuit.
Circuit.
All right, I'm going to put circuit up here um, on my word wall. A circuit is a complete and circular path around which electrical energy can flow. Let's say circuit together again. Circuit.
Circuit.
Now, for our EBs and our Spanish speakers, notice that circuit and circuito are very similar. They're cognates. I probably said that wrong. Words that look the same and they sound alike in different languages, but they have the same meaning. So for circuit, we're going to make a circle with our arms to show a complete path. So I'm going to do like this. So let's make this circle. All right. And I'm going to continue reading. A circuit can have an open path or a closed path. In order for electrical energy to travel, the circuit must be a closed path or a complete circuit in which electrical energy can flow. All right. Our next word is, what do you think it's going to be? Closed path. Exactly. Because you see that word highlighted right there. I'm going to take closed path and put it right here. A closed path is a complete circuit in which electrical energy can flow. I want you to look in that text, pretend the text is on your screen, um, and notice how the text actually helps us understand closed path by explaining it as a complete circuit. The word complete, we know that means we're done, gives us a clue about what that means here. So for closed path, let's connect our circle by bringing together our hands to show that it's complete. When there is a closed path, the electrical energy produces the power needed to make things work. You can think of a closed path as the loop that has no beginning or ending around because there's no breaks in the track. And that's exactly how energy needs to flow in a complete loop. Now, what are some examples of things that are in a complete loop? Exactly, a racetrack. So I might have students actually draw a racetrack to show that that's a closed path, or maybe a necklace. So I'm just dragging these here. But as you're doing this with your students, these are opportunities where you can give them an index card and say, give me some examples of a closed path, and so on. For electrical energy, we could have put up here this lightning bolt or this socket here. So that's kind of how it goes when you're building it with the students. Um, Again, this was what I was reading from. And this is what it would look like if it was done. And so all of these images of here would, some of them might be actual realia from the investigation. Like if you were actually like had the battery, you could just put the battery up there in a Ziploc bag or something. Or like a toaster, we're probably not hanging a toaster on the board. So you can have students draw pictures of the toaster, or whatever you want to have, make sure that they have some input. All right. So again, you would continue through that. And again, there is a sample script. Don't have to read it, but it is there to help you. And it also infuses in all those word learning strategies so that you don't have to remember to say them. One thing I do want to call your attention to, because in McGraw Hill, this slide is where the investigation ended. But so here are the next slides, and it'll say in the notes here that the following 7 slides provide an opportunity for students to see and discuss different configurations. And there is sample script for each of those. So that was not there. So there's 7 configurations for you to go through, and you can talk about use those however you want. I just wanted to get some more types in there. Now, this last one is a doozy. You don't have to do that one. It is a challenge one, but if we're trying to get students to master grade level content and not just meet it, we got to push them a little bit. So this is not something that they have to be able to answer, but it is definitely a good practice of doing that. After that, in your presentation, generally comes the elaborate or possibly like an infographic or something like that. Um, this particular one, this is the infographic. You have this picture, this picture. So that is linked. I mean, that is already in the slideshow. However, um, there is a link here to the actual um, infographic. If you want to pull it up, it does have some arrows and stuff moving and showing directionality. If you are already logged into McGraw Hill, you can actually click that link that's in the notes there, that slide, and you can actually pull that up. This is the Illiteracy Essentials for Electrical Energy Travels. There's a teacher guide for it. There's a Spanish version of it if you just need them to read something. This is like an additional thing if you have time for this. This is not something that has to be done, but it's definitely a good practice to give students this. You can also assign it in McGraw Hill. That way we're not having to print out a whole lot of paper. And then here we have the reasoning slide. In this slide, there is a sample reasoning down there, and there's some notes for you about what they may write for that reasoning, um, and then some more sentence stems. This is something that you could use as an exit ticket if you wanted to, but just make sure students are using these words and can actually fill in the blanks of these verbally and in writing. This is the elaborate for this particular lesson. It's about electrifying eels. So there's a reading that's on this slide. Yes, that's the whole reading. Um, and then there's a video here, and it has them doing some research. I did put a few links that you can just share with them for that research or fun facts about electricity. Um, you're welcome to use other ones. I just kind of glanced at these and thought those would be good to have. Here is our lesson review slide where you go back to the page Keeley Probe. You might revisit the interactive word wall or talk about claim evidence and reasoning, or complete the lesson review assessment, which we'll talk about that in just a minute. There's a slide here that this image links to a folder that has all of the foldables in it. It's not possible for you to do all of them. If you like foldables and like doing stuff like that, I think the kids actually enjoy it. It gives them something tactile to do. And there is a link here in the notes that's a spreadsheet that has videos on how to do the different types of foldables. So definitely look at that. Here we have where it says that you've been assigned the Learn Smart for 4.8C. If you're not familiar with Learn Smart, it's just an adaptive review. I would say it's similar to iReady, but for science, where it gives students questions based on a particular teak, and they answer them. And I'll show you that in just a second in the actual platform once I finish this. Here we have the lesson review, and this is what I would probably take as a grade. It's about 5 questions. Sometimes some of them are you have to write answers, and some of them are multiple choice. But it's for just that lesson. So if you want at your day 5 of the lesson, or your day 4, whatever you want to give it, just to kind of see how much they actually know. All right, now I'm going to get out of here. I'm going to share this tab. And I just want to, before we end, show you how to assign those things. So I clicked on McGraw Hill. I'm going to go to browse this course. I clicked on chapter 4. I'm going to click on the second one since that's the one that we were doing it for. Give that a second to open. And if you look here under the differentiate and accelerate tab, that's where you'll find those individual like 4.8C Learn Smart. So I'm gonna go ahead and assign this. I'm gonna click ungraded because I don't want to have to put in that information, and it's assigned. Now, here's what I want to show you. Once you assign it, go over to where it says assignments, which is right here, and click the little three dots and click edit, because this is a really powerful thing for you to see and be able to edit. So I'll give that a second to pull up. Basically, um, what I'm going to be showing you is how you can drill down to see exactly what concepts are going to pop up in Learn Smart for students. You can actually see some sample questions, and usually this goes perfectly. But of course, today it's spinning. So let me refresh, maybe. Okay. So here it is. Over here, you see it says edit content. So I'm going to click edit content here. And over here, it says there's 4 concepts selected. It's going to take them 6 to 9 minutes to do. This is also really cool that you can actually see how long it's going to take to give them to answer the question. And you can see that this is 4.8C, but you can also drill down into the concepts covered in 4.8C and see that all these boxes are checked. If you didn't want to do one of those concepts, you could uncheck that box. Okay. Or so you can check individual boxes or you can check them all. You can also preview a sample question for each of the types. It's not going to be the exact question because these are adaptive tests, so it doesn't give every child the exact same question. Um, but you can at least see an example. And then after the 6 to 9 minutes of them actually answering whatever questions they have to answer, depending on how they scored, it will give them various things to practice. It may give them an infographic. It may give them science literacy essentials. It may give them an interactive investigation to do from a different grade level. Those are the types of things that you should have them doing, not necessarily during science time unless they finish something early, but rather like if they have morning work time, like or they have time in a flex time, or they finish the assignment early somewhere else, be like, go on Learn Smart and do that for 10 minutes or so. Okay. We'll get back to here. And that is pretty much all that we have for you with that unit. Again, this is a recording that we did primarily for our just in time section, but we are going to try to do these recordings for all of the units eventually that will come. If you have any questions or concerns about anything, please don't hesitate to reach out to either myself at Skid Little, better known as Professor Spark, or to Gwendolyn Island, better known as Bilingual Blades. Until next time, happy sciencing, and I will talk to you later.